So we have 88 used car sale costs. The sample mean was 6,525 and the standard deviation is given. So which distribution should you use? You should use T87. Now I know I'm using the T distribution because the population standard deviation is not given. So I'm going to do T, and then it's under functions. And you can use this. It's going to be T87. It's the degrees of freedom, which is n minus 1. Your n is 88, and so 88 minus 1 is 87. So the student t distribution with 87 degrees should be used because the standard deviation of the population is known. If we knew it, then you would want to use the normal distribution. So what is X bar? X bar stands for the average, but it's the average of the used car sale costs. So it's the average cost. And it's not the average cost of all used cars, but just of the 88 that we sampled. Okay, so now to do the confidence interval, well, we could, it's a 95% confidence level, so 0.95. Now, 1 minus 0.95 is 0.05. 0.05 divided by 2 is 0.025. So there's 0.025 on each side. And then we need the confidence level. All right, so we know that the confidence level is 0.95. 1 minus 0.95 gives you your alpha, which is 0.05. And then 0.05 divided by 2 gives you 0.025. So that's why when you see the chart, you have 0.95 in the middle and 0.025, and all three numbers add up to 1. So now to create that confidence interval, the first step is to do z alpha divided by 2, or not the z-score, actually t alpha divided by 2. And let's see, if it's a t distribution, the n is 88. Your degrees of freedom is 87, which is n minus 1. So 88 minus 1 gives you 87. Now this is actually not on the t distribution, so we're going to have to use StatCrunch. So here's our t distribution, and our degrees of freedom's 87, which is not on this chart, so we're going to use StatCrunch. So in StatCrunch we go to Stat, and we're doing t-stats. We're only talking about one sample here with summary data. Now the sample mean was 65.25, the sample standard deviation was 31.59, and the sample size was 88, and the confidence interval is 0.95, and then we compute. So we have our lower limit, which is 55.6719, and our upper limit 7194.3281. So we'll enter that here. So we want to round to 2 decimal places, so 58, 55.67, and 7194.33. And we're just going to take these same, I like to just copy and paste it here. Okay, and now to find the error bound is what you plus and minus. This is our last question. So to find the error bound, we know that the middle part of the data is our sample mean, which is 65.25, and the upper bound is 7194.3281. So the error bound for the mean, well, to find your confidence interval, it was X bar plus or minus your error bound for the mean. But if you're not given the error bound, then what you're going to do instead is plug in the upper part, 7194.3281 equals X bar, which is 65.25 plus X. And when you subtract 65.25 from each side, you get 7194.3281 minus 65.25, which gives you your EBM. Your EBM is 669.3281. You could also do that for your lower bound. So the lower bound was 5855.6719 equals X bar, which is 65.25 plus X. You could actually put EBM here. plus EBM. So to solve for your EBM, you're going to, or minus, right? One is plus and one is minus. You're going to minus. So minus 6525 from both sides. So you get 5855.6719 minus 6525 gives you negative 669.3281 equals your negative EBM. Divide both sides by -1, so EBM is 669.3281, which is the same thing we got here. So you plus and minus by the same amount to get your lower bound and your upper bound. So your EBM is 669.33 if it says for 2 decimal places. So again, to find your EBM, you take this number minus this. And you don't have to do the lower bound too. I was just showing you that it's symmetric. I think it's easier to do the upper bound to the upper bound minus your sample mean to find your error bound for the mean.